稍等一下下，因为上厕所。打电话。
那个密码踢进去动不了，帮我交机动组。
你说时钟的吗？
那个考不了下一个 stage。
刚刚没说上一集的时候，我就发现超级热好。这很不好意思。
下次比我就没办法比我好，再准备一下就是。
确认一下情况，好了吗？好了，
又
可以了，谢谢。
The opponent challenges the reporter for problem. 1 minute. Team Lighting want to challenge problem 7. Here's 7 dice. We accept the challenge. Preparation of a reporter, 5 minutes. I will start. I would like to start my presentation. Right. Presentation of the reporter, 12 minutes. Okay. Here there is an fellow and the reporter from Singapore and report number 7 dice. And this is a problem statement, and the problem asks us to find the physical and geometrical characteristics of a cylindrical dice so that it has the same possibility to land on its side and one of its face. And there's some big question: what is the characteristic of pair three-sided dice? And does the pair three-sided dice exist, and how does friction affect possibility? So it is a demonstration, and this is a table of my presentation. Okay, so here first comes some analogy, and we define the top and bottom surface as face, and rest is side, and h is height of cylinder, and d is diameter of cylinder, and this is a side view of three-sided dice, and this angle is phi. So aspect ratio will equals tangent phi will equals h over d. So to simplify the static mode, so we should have two assumptions, and the first is the result only depends on the contact angle theta and the geometric property phi. Just means this angle. So which means that we don't consider the rebouncing of the cylinder. And the second is contact angle theta between 0 to 180 degrees, and this is even. And so that means the position of center of mass determines the result as it controls the direction of gravity torque. As the case 1, it will land face up, and in the case 2, just assume the gravity torque will pull the dice to land on its side. So according to the assumption and the reasoning, we can find there will be a probability function of h and d will equal 2 pi over pi. So a pair three-sided dice you have often p in 3 and 1/3, and in this case phi should equal 30 degrees. The aspect ratio will equal 1 over the square root of 3. And to test our model, so we conduct an experiment. So we toss the cylinder with spinning and flat smooth stone and smooth surface by hand. Toss each cylinder with different aspect ratio 2,000 times to count the possibility of landing on its side. So this is the result. And the red line is theoretical line, and the black line is our experiment data. So at this part, in reality, when the ratio is small, the dice is much less likely to land on its side, and which is because the linear velocity, angular velocity is easily make a simple fold. And in this part shows the theory predict lower possibility of landing on side when the ratio is larger. So we take a closer look. That show the fair ratio predicted by the model is larger. So it definitely has some, there are some influence of physical conditions. So let's talk about it. So we should introduce some the concept of initial condition. And first, there are some two facts we should know. And first is the identical condition produce only one certain result. But if we control all the initial conditions, there is no concept of probability. So the probability is based on a range of uncertainty initial conditions. And this is the diagram of a cylinder. So this terminology, and V means linear velocity, and omega means the angular velocity, and vector n is the one normal vector on base. And there are two extra conditions of experiment, which is experimental conditions. And we found an amazing phenomenon. So this is observation. When rolling, the cylinder seems to have a higher possibility to land on its side than dropping. So we conduct the experiment to test this phenomenon. So we find out just if the linear velocity of cylinder is higher, and the possibility will higher. And okay, so we can discuss about the horizontal linear velocity, and this is the diagram of the cylinder. And if a cylinder move like this way, and this is my linear velocity, and this is friction, so the combination of force will point this way. So the delta L equals R force, the combination of force. And so the friction and normal force create a angular momentum while the cylinder contact the surface, and the new angular momentum makes the cylinder tend to contact the surface outside. Okay, so we use the simulation and to approve this concept. So this is the result. So we can see definitely when the cylinder has a higher initial velocity, the possibility will get higher. So consider other initial conditions like angular velocity when my cylinder is spinning. When it touches the ground, it will transform the energy to linear velocity. So it's easy to think that all the initial conditions will affect its final possibility. So we can know that according to the reasoning we mentioned, we can know the possibility is the function of all the initial conditions, and as you can see, there's too many factors of this function. So we can know the function is almost chaotic and hard to predict. So we will just discuss some qualitative analysis. And according to this function, we know different range of initial conditions leads to different possibility of perfect suicide that does not exist. So in our experiment, as you can see, the different ways to tell does affect the possibility of possibility. So there is the explanation. Different ways to tell will also affect the velocity. So the possibility also will be affected. And we conduct the experiment to prove the friction, the effect of friction. So we use the three material of floor, and in the experiment that shows that the friction does exist possibility. So this explanation, as I previously said, the friction a larger friction will also make a greater variation of angular momentum. So yeah, it does affect the possibility. Oh, okay, and then I will make the conclusion. A higher horizontal linear velocity may have a higher possibility of landing on its side, and bigger friction may have a higher possibility of landing on its side. Perfect paradise does not exist in reality, but we can only find a fair cylindrical dice under a certain range of random initial conditions. Okay, thank you.
Questions of the opponent to the reporter and answers of the reporter. 2 minutes.
So my first question is so you don't think that there's a suicide dice in the reality?
Yeah.
Please turn to page 25.
25?
And here's the formula for it. question. Could you tell me the meaning about it?
Okay, so when I toss a cylinder, it will have some angular velocity, right? So it will have the angular momentum. And when I when the cylinder hit the floor, and the floor will give the normal force and the friction, and will cause
Please turn to page 20.
sorry,
And that page, you have said that there's a P and there's many vectors. Do you consider all of the vectors?
all of the vectors. It means the orientation or
Do you consider all the things that
in my presentation I said the vector is too many, so it is a chaotic system. So I don't consider all. I just make some quantitative analysis of my problem.
And if you turn to page 17.
Sorry.
At that page, you have mentioned about you using a program to visualize. And does the result correspond with your theory?
Time's up. Declaration of the proponent, 3 minutes.
我 key 个进去，然后在上面，然后就让就一直点，他们都会在那边。然后但是我们到下个 stage 输入码一直没来，就是但是有课有学。
因为我要确认他是说分数还没有提上去吗？
因为我们 key 过了，
都提过，
都 key
第一场的
第二场，现在就第二场。那应该是有可能就是 key 的时候那个网络出问题。有可能是这样，因为我们刚才遇到是 key 的密码，但是整个都动不到，但有一个怀疑是网络。
Right, so the opponent takes the floor maximum 4 minutes, and it will be followed by discussion between the reporter and the opponent.
Honorable jurors and competitors, I'm today's opponent for problem number 7, three-sided dice. And the first is a problem statement, and I think that the reporter has mentioned before. And it's basically want us to find out the physical and the geometrical characteristics, and to find out the same probability to land on its side and one of its faces. And here's my summary and comments for the report. And let's first start with the theory, which included terminologies, simplified static model, making a fair dice multiple equation, and a different initial condition. And then he did some experiments about using a graph to display the result. And he has some variables, like a horizontal linear velocity and a probability to velocity. And then the last is the conclusion. His conclusion is the higher horizontal linear velocity the cylinder gets, the higher probability it can land on its side. And then the advantage for the report, the first is the reporter's experiment process, and then the complete theoretical analysis. And the third is to provide sufficient amount of experimental data. And the fourth, he has a complete conclusion. And my suggestion for the report is he can give more variables about the experiment, and he can have a more time management. And then it's the next point I want to raise. The first theory, I want to ask about, do you investigate physical characteristics of the phenomenon? And then the setup and the data. The first I want to ask is, should the bounce of the dice be tracked? And then I think in the reality, the dice will bounce. And I want to know that if that will affect the result. And then can the surface of the base be your variable? And then about the experiment and the parameters. The first is, will the material change your results? And then will the hollow or solid dice have different results? And I think that for the hollow and the solid, they might get different results from when we're throwing the dice. And different material may change weight or other the surface of the dice, and it might change the condition. And then that's all my presentation. Thank you. Okay, so please turn to page 10.
Page 10.
Okay. So you can see that your result isn't really correspond with the theory.
Yeah.
Then why do you think that there's any in your experiment? Why do you think that it won't correspond with the theory?
As I previously mentioned, I think if the dice have the high linear velocity, it will affect the probability. So when I toss, whatever I toss, the dice it will have the linear velocity, right?
So the theory didn't consider about the linear velocity.
Sorry.
The theory didn't consider.
Yeah. So I think the theory is so wrong.
And do you think that the way that you release the dice will change affect the result?
Yeah. I just show the result of our experiment.
Why do you think that will affect?
So I compared different ways to toss. One is the roll. I roll the cylinder along my hand, and the other is tossing cylinder vertically. So I think the difference of the two ways is not the same.
So do you think that when you let the dice hit the floor and rotate, would that the possibility to land on the side increase?
Yeah.
And so do you investigate physical characteristics of the phenomenon?
About what?
Okay, maybe
What
you
is
can
I just investigate the velocity and angular velocity.
Okay, I want to raise another question. Do you have ever considered about the bounciness when you join the dice?
Bounciness, yeah. There is I can reasoning for it. Make a reason for it because I mentioned the friction and normal force. Just the moment that that dice hit the ground will affect its possibility, right? So this normal force is related to the bounciness, right? So I will definitely
bounciness increase, what will happen?
I think you can. I think the 3D diagram is too hard to imagine, but
Take a guess.
I see that if I adjust the normal force more bigger and the changing angular momentum will point more forward, like just okay. But it just also parallel to the ground.
And do you think that the surface of the dice will affect the result?
Yeah, I think it will affect the coefficient of friction. So I think
Just like this.
yeah.
And we turn to page 7.
87.
Okay, and you have said that 1 over root 3 is what you get from the theory.
Yeah.
So, but you have mentioned that in reality, this might not be here, and so might not exist. So, in what condition do you think that the three-sided dice will exist?
Okay, so the assumption of this this model, we consider there is no responding of my dice. So if the dice won't respond, and so I think the model will fit the
With the constant 0, then
Yeah.
that will be perfect.
yeah the theory will be.
Then could you point out in your theory why do you think that when the constant is 0, that will the three-sided dice will exist?
Okay. So let's go to that goal. So I think the possibility of my finger was my possibility is distributed evenly. That means the possibility of my dropping angle will distribute evenly, right? So if the dice won't rebound, so if this angle be 30 degrees, and this angle 60 degrees, and this angle 6 degrees, and the possibility of these two angles will be 1/3. Yeah.
Could you turn to the page where you show you roll the dice?
I roll dice for the observation.
Experiment in that is for the figure. Oh, here. Okay, so could you tell me how to throw the dice in this video?
I just click pause project the dice.
do you think that every time you throw a dice will, because we can't really make sure that we...
Yeah, I can make that every time the dice will erect, but I can say the possibility erect will very high.
So you think that when a dice that keep hitting the floor and the possibility of landing the side will increase?
Yeah.
And what if we use a floor, right? If there's a side, and if we put our dice here and just like this, like down, and it will still be possible to land it in the floor. Do you think that will be better to do the experiment?
I think in my explanation, I think it's not so important. The important is times of my rebounding. So the release, the method of my
the times of rebounding. So do you calculate the time that it rebounds?
Calculate all you mean in my experiment?
Yeah.
Oh no, we just fix the linear velocity.
And so do you think that when it bounces for more time, the possibility will increase or decrease?
Yeah. Yeah, I think it's right. It's like okay, so I think the main point is linear velocity.
And do you think that if the dice is hollow or solid, will that affect the result?
I think it won't be too much because if my dice is hollow, it just will have some deformation, but it won't affect the possibility too much.
So you think that deformation of the dice will also affect the
And maybe it will affect the normal force of the dice.
So you think that the normal force in your dice plays an important role in this experiment?
Yeah, important.
Do you consider about the weight of the dice?
Weight of the dice. No, but I think it does affect the possibility.
So if you increase the weight, do you think what will happen?
So if I increase the weight, and first is the normal force will be increased, and if I increase my mass of my dice, the energy will decay more faster, but hitting the ground. So
Could you tell me that how the energy decays when you throw the dice?
okay, I can show the diagram of my presentation. So when my angular momentum is not this direction, it's like this. So the delta L will modify the angular momentum. It will modify to this direction parallel to
In what
the
form?
the
In what form do you think the energy will last?
And I think in this moment it will lose its energy by the friction and in a moment.
Hold on, summarize the discussion, 1 minute.
And from discussion with the reporter, we have discussed more variables that we want to discuss. And also, the reporter has mentioned that in a horizontal, the near velocity, the normal force plays an important role. And in many experiments, when we change the variable, it will relate it to the normal force. And I think that some of the experiments can be more accurate to increase the accuracy. And of course, the reporter has ball theory, but I think there's a lack of the relationship to the theory and the experiment. And I think that's all my summary. Thank you.
Questions of the reviewer to the reporter and the opponent, and answers to the questions.
Okay,
3
thank
minutes.
you for the reporter and the opponent. And the first question of our team is, do you think the probability to land on the side and the faces will be continuous? Like continuous?
Not really, because I don't really conduct.
Okay, and how about you?
What do you mean continuous?
Like the face is just like a line?
Oh, you mean
The probability of falling on the side?
there's no one dot and one dot, a dot, it's just a line.
Yes? Is there
I
a line?
think
Yes or
it's
no?
not really.
Okay, yes or no? Yes or no? Okay.
Because as
Okay, I want to ask another question, and just assume if everything is random, will there be a will there be a three-sided dice? Like everything is random, just assume that. Yes or no?
Yes.
Okay, and the third question is, just please turn to page 20. Just like, is this all the parameters like have the equally matters
Equally matters.
of this? Yes or no? Equally? Do you think this is equal? No. Yes or no? Okay, and number 4 is, which of the linear velocity and the angular velocity have the greater effect? Which one?
I think you can just say if the linear velocity just directly affect the possibility, so but the angular velocity does affect the linear velocity, so I couldn't say.
Okay, and how about you?
I think the near velocity.
Okay, the fifth question is, how would you change your initial condition so that if, is that possible to just always to land on its faces?
Always
Land on its faces?
Always land on its faces.
Because you say that you can control the angle or something, and you can always land on its side. So it.
I just let the y equals 0 and I just put on the surface and.
Okay, and do you think it's possible to just always land on its faces, just like still, just keep the, yes?
I think that's not possible. We need to observe about it very well.
Okay, and the next question is, how did you get the experimental setup? By handmade or 3D printer? Your experimental setup, the dice,
Setup.
how to get the dice?
I use the 3D printer.
Okay, and how about you? Do you think 3D printer is the best way? Okay, and the next question is about the structure of the dice is uniform, so the mass is all uniform, so the
Time's up.
okay.
Declaration of the reviewer, 2 minutes.
Thank you for reporter and opponent, and I'm the reviewer of this question. And here's the problem statement, and we focus on the physics characteristic and the geometrical characteristic. And the reporter says they focus on the characteristic of the fair three-sided dice, and does the fair three-sided dice exist? And here's the summary of the report. And he investigates the phenomenon and about throwing a cylindrical dice, and the theory that he used is the center of the mass and changing linear velocity and other physical characteristics will affect the results. And also the experiment that he did is simulate by different angles and different ways to throw the dice. And he also explained about parameters and probability to the velocity, and he also told about, and he also have some experiments in his report. And the process have many parameters like the angular velocity, and gives a clear explanation of the force analysis. And he has a clear understanding of the theory. And the cons is poor observation video, because we can see the consequences in his observation video, and there's no connection between the theory and the conclusion that he used the theory, and this also the opponent just said. And he has a poor time management because of and to focus on the parameters like the linear velocity and also some kind of the angular velocity. And he also didn't give the conditions when the dice will land on its faces, because and here's the pros and cons of the opponent. He has a clear question asked, and he has asked about the weight of the dice and more variable about it can improve and the normal force. And here's he also asked about many parameters and related the normal force. And cons is that he didn't give a suggestion to approve the experiment like his own opinion, and did not realize what the theory in the beginning indicated. So here's the first question and discussion about, and it's the consequences that doesn't fit the theory. And the reporter just said that we have to consider the velocity and the linear velocity, and the opponent just asked about why the consequences doesn't fit the theory. And in our opinion, we agree with the reporter, because the theory is only considering the geometrical characteristic, and the center of mass is also called like the center of gravity, but there's also physical characteristic. And the next question that I discuss about is the bouncing effect of the dice, and the reporter says that bouncing will not affect the dice. The main point is linear velocity, so that's the linear velocity causes the bouncing effect of the dice, and the opponent says that bouncing could affect it and should be calculated, and the bounce times, the possibility will decrease if bounced more times. And we also asked this in the partial question, and we think it's affect because the initial condition will change once it makes contact with the ground, and they also say the initial condition is not always the same. And the question they discussed about is the hollows or solid, and the reporter said it wouldn't affect it, only the same, but affect the normal force, and opponent said it would affect it, and the reviewer, we agree with the opponent because it changed and its physical characteristic like the momentum may change. And here's the missed point of two teams, we have asked in the short question and the experiment consequence. Okay, thank you. Thank you everyone.
Concluding remarks of the reporter, 2 minutes.
So here's my concluding remark. First, the possibility is determined by many different variables, and the fair three-sided dice may not exist in reality, but only under same constraints. And bouncing of the dice is hard to track, but does not make it when consider only geometric characteristics. And then and material influence, we already consider the friction coefficient, but deformation may affect the possibility. And also halo or solid dice, the difference in moment of inertia change the behavior of rotation, so it does matter the possibility. And thanks to the opponent for providing the method for more control initial condition. So to think that if all the initial conditions are the same, not just ones we can control, but also variable like airflow, air particle distribution. Okay. We can get the same result every single time. For example, instability of certain landing situation equals 1, while the other one equals 0. However, control all initial condition is not particle. Okay, thank you.
Right. Time for questions of the jury. Please.
I have a question for review and comments first that there are more than one kind of mission for the cylinder dies, I think. So do you think it's proper to simplify and important to simplify the parameters like H divided by D ratio? Do you think it's proper?
Okay, I think if only talk about the geometrical, then the ratio will be 1 over √3.
We think we can turn in this way. The answer is no, because of the SS is not the same.
Do you have any comment based
I
on
think the model just consider the 2 dimensions, not consider the 3D dimension, 3D condition. So,
Other questions?
Second question for the report. I want to know, for in your plot, how many times did you do for your solar dice for each day?
I throw about 2,000 times.
2,000 times.
Yeah.
So you got the I believe sometimes for example you optimize the 0.3 something, 30% something. So do you have the plot for I think for one of the I forgot for each page. So
Okay.
the probability for the ratio it's 81. Okay. So what means is if you want to find out a fair three-side dice, so what's the ratio for the 2 parameters, the height and the diameter of the series.
Okay, so I think just like the previous mentioned, there's no fair three-side
No,
dice.
yeah. So okay. Let me clarify this. If you throw these three-side dice, just like your toss coin, okay? So there's no fair three-side dice.
Yeah.
Your competition. Okay. Your opponent, do you agree with the result from the before?
There's no mean that I've used some program to do the experiment, and I didn't really found the fair three-side dice that will land on the side.
You agree
yeah.
Okay.
But maybe in the reality, maybe because we can consider more conditions, maybe that will help the three-side dice to form.
How about you?
I think there may be a three-sided dice, and if the diameter divided by height may be like just √3, and it will be the three-sided dice. And because of the initial condition, so in the reality that may not be able to have.
If we get just like toss the coin, the initial condition will.
So it's just like throwing in the computer or something, and it may be happy, I think.
Any other questions?
Yeah, just a short question. It seems that all of you just consider the probability between the top and button and also the sidewall. But have you ever considered that the top button asymmetry induced by 3D printing can affect the result?
You means
The top button asymmetry. at least the fatness is different.
In my experiment, I always check my data that the face and the top and bottom completely the same, and I think the data is right.
You confirm that?
Yeah.
So do you agree with that?
I think that depends on how you throw the dice.
I mean, the top button fatness difference, can it lead to the different result?
I think it may be different, but only slightly.
And how about?
I think in the theoretical, and it will be the same. If I say before, if I throw just by a computer or something like the app, and it will be the same.
But they prepare the example by 3D printing. For sure, the top and bottom surface are different. They prepare the experimental.
Yes, in the reality, we accept that because of the initial condition, we agree with the reporter, so they may not be able to have a dice like that way. But if we throw by the computer, it may have happened. The ability of falling on the top and the bottom will be the same.
Okay.
For sure, please mark your grades. Okay, so the grade for reporter 7, 6, 5, 5, 6. 6. Right, so now the grades for opponent 5, 6, 5, 6, 6. Right, so now grades for reviewer 8, 7, 6, 6, 7.
Okay.
Right, thank you. So we will have 10 minutes before next round.